At the end of the last video in the matter video series, we ended with this slide, which said atoms can achieve a stable or closed valence shell by either donating or accepting electrons or by sharing valence electrons with another atom. In this video, we're going to focus on the donation and the acceptance of electrons, and the best way to explore this is with an example. So here we have two atoms. On the left is sodium, on the right is chlorine. Both of them have as their current valence shell the third shell. Sodium has 1 valence electron, chlorine has 7. Both of these atoms are equally close to stability, to having a closed shell. At first glance, a lot of people have trouble seeing that. They see that, oh, well, chlorine has 7 valence electrons. The third shell is closed with 8. If it just gets 1, it's full. It's closed. It's really, really close. Oftentimes, people will look at sodium and say, but sodium's not close. Sodium needs to gain 7. What you have to remember is the valence shell is the outermost shell occupied. In order for there to be any electrons in sodium's third shell, the second shell has to have 8 electrons in it, which would be a full or closed shell if it were the valence shell. So in the case of sodium, if it just gets rid of 1 valence electron, its valence shell goes from the third to the second, and the second is already closed. So if sodium could get rid of 1 electron, it would become closed and stable. If chlorine could gain 1 electron, it would be closed and stable. And I hope you can see where this is going. Let's see what happens when sodium gives an electron to chlorine. Now, something happened here. Aside from the fact that the two shells are now closed, there's something else going on. Notice sodium started out with 11 protons and 11 electrons, but now it only has 10. Whereas chlorine started out with 17 protons and 17 electrons, and now it has 18 electrons. Sodium has taken on a positive charge. Chlorine has taken on a negative charge as a particle. And if you remember from earlier, atoms are electrically neutral. An ion is an electrically charged particle. It can either be positively or negatively charged. We call them cations when they're positive and anions when they're negative, but they're charged particles. That's what's happened here. We've gone from a sodium and a chlorine atom to a sodium cation and a chloride anion. They are now charged particles. Just as a side note here, we use the term electrolyte in biology to refer to substances that dissociate or dissolve or fall apart in water to form ions. Sodium citrate and monopotassium phosphate, for example, are electrolytes that you commonly find in sports drinks like Gatorade. They dissociate, they yield sodium ions, potassium ions, and phosphate ions. The term electrolyte doesn't come up much in chemistry. It's really more of a biological concept. And it's not a term I use an overwhelming majority of the time in my own courses, but it is something you see in the literature, especially where nutrition is concerned. So you're better off knowing what this term means. Very important fact. Opposites attract, sames repel, at least in terms of electrical charge. We have here is a sodium cation and a chloride anion. If you think about this, these two particles had to get pretty close together in order for sodium to donate an electron and for chlorine to accept it and become chloride. And so there is an attraction between them. And that attraction is what we call an ionic bond. An ionic bond is the attraction between oppositely charged ions. It's a first form of chemical bonding that we're going to deal with. It's worth noting, ionic bonding doesn't lead to the formation of molecules. The sodium and the chloride ion shown here are still discrete particles. They're attracted to each other. If I add more sodium and chloride ions to this mix, they will be equally attracted to their opposite and repelled by their same. So as I start adding ions to this mix, we see the chloride and the sodium ions interacting to form what we call an ionic compound, sodium chloride or table salt in this case. An ion is an electrically charged particle. It's the product of one atom donating an electron and another receiving it. The attraction between oppositely charged ions is called an ionic bond. There are some common cations and anions that you ought to know because they come up a lot in human physiology. And here's your list of 9. Bicarbonate, calcium, chloride, hydrogen, peroxide, magnesium, phosphate, potassium, and sodium. Make sure you know how to correctly write each of these cations and anions, including having the charge correct.